Okay, I think we are ready for the second part. Good afternoon everyone and welcome to today's session, Navigating the Future with Convergence of Digital and Green Transformation, which is very important for all of us globally. In an era marked by rapid digital advancements, we find ourselves at a critical juncture where the vision of technological innovation and environmental sustainability can set the path of a thriving and resilient future. This session provides us a unique platform for researchers, industry experts, and us for policymakers to join forces and discuss how digital platforms can act as a powerful drivers of positive change while safeguarding our planet. As we gather here, we are witnessing the remarkable transformation in various fields. Smart cities are evolving from ideas into real, data-driven ecosystems with urban spaces increasingly optimizing energy use, managing waste and adapting to real-time needs. Similarly, in agriculture, digital tools are enabling unprecedented precision, allowing farmers to manage resources more efficiently and sustainably. These are just few examples of real-world impact of RTOs, which are pushing the boundaries of innovation while keeping sustainability at the forefront. This session is structured into two key breakout sessions. The first part, Innovative Technologies for Green and Digital Transition, will highlight cutting-edge technologies and practical strategies that bridge digital solutions with sustainable practices. We will hear from experts who are leading projects in water management, renewable energy optimization, and the integration of digitalization in managing our resources more wisely. And in the second part of this session, strategies and policies for digital and green transition, we will look at broader strategic and policy approaches. Our speakers will share their insights into frameworks and approaches that support sustainable technology integration across industries. This session aims to foster a dialogue on how policy and industry can work hard in hand to overcome challenges, scale up successful practices, and drive green and digital transformation on a global scale. Our day will conclude with a panel discussion during which we encourage all you active participation from all of you. We will collect your questions and our esteemed speakers will provide their perspectives all in this engaging Q&A session. And thank you for being here and for your commitment to this cause. I'm excited to start this journey together, exploring how we can leverage technology to create a greener and, of course, more resilient world. Let's get started with our first session. We are privileged to host distinguished speakers who bring huge expertise to this event. And our keynote speaker, let me introduce Wang Tao, Professor Wang Tao. I would like to give the floor to Professor Wang Tao from Tongji University, China, to provide us the broader landscape of digital and green transition, outlining how technology and environmental strategies intersect for sustainable development. Thank you, Professor. The floor is yours.
Hello. So I'm very happy to meet you in this conference. My name is Tao Wang from Tongji University. So I'm going to introduce some of our work in this area. This is the title of my talk. Originally, the talk should be presented by my boss, our team leader, Professor Huan Zhengdu, but he's very sorry. He's in another meeting in Beijing and cannot come back and to join this meeting. So I think this is not good for him, but this is good for me actually. So I take the chance to somehow introduce our work for you, and I'm ready, and I'll be very happy to get some feedback from you. So actually, we are all working in the area we call the circular economy, the environmental conservation, resource conservation, and also the ecological civilization, some of the national policies in China. And Professor Du is a key expert in the consulting panel for a lot of the ministries in China, including the National Development and Reform Commission, Ministry of Commerce, and somehow the Ministry of Industry and Information Technology. And because of his contribution for circular economy, 6 years ago, or 5 years ago, he was in the finalist of a global circular economy award called the Circulars. And this award is actually delivered by the World Economic Forum, together with some other international guests, including the first man. He is the head of the Denmark Circular Economy Association, and also there's another Asian. He's actually an American architect, and the third man, he is the Finnish environmental minister, plus my boss. So that's our work and our influence in this area. And today I'm going to introduce 3 parts. The first one is about ecological civilization and green development, some of the national policies. I see there are many international guests in this room. Probably you are interested in the national policies in China. So I just introduce very quickly. Then the second part, I'm going to introduce a little bit about our understanding of how digital technology and digital economy can help the green transition and green development in China. But I must say, actually my work centered on green development, on environmental areas. So somehow I'm not an expert for IT, for digital economy or digital technologies. So I'd like to learn from you, for this part of talk. And the third one, and also I'd like to put more time on the third part, is I'm going to introduce some of the applications, the practical projects we are doing now with our industrial partners. So we are trying to apply to use some digital technologies for waste management and for circular economy and for resource recycling. So that's about my talk, the first part. So I must save my time. In terms of ecological civilization, that's actually a national strategy in China, and this strategy can be somehow tracked back to 22 years ago from the 16th National Congress of CPC. We know that each national congress is actually a milestone for the policy for China in the following 5 to 10 years or maybe even longer. Then the ecological civilization is actually become a very important part of a system, plan for the Chinese socialism. It was in 2012 in the 18th National Congress. And also on that National Congress, President Xi Jinping became the leader of China. So I apologize, some of the policies in Chinese, but I'll try to translate and to explain to you. If you are interested in the national strategy or the national policy system in China, then somehow we call this five-sphere integrated plan or five-in-one plan. The one is here, the socialism with Chinese characteristics. That somehow, I mean, the expression of China's social economic program, the development, the whole task and design. Then to make up the socialism with Chinese statistics, then we need to do five-dimension tasks and work, including the political development, economic, culture, social development, plus ecological civilization. And actually, in his report to the National Congress of CPC, President Xi Jinping mentioned we must give high priority to make ecological civilization and to incorporate ecological civilization into all aspects and whole process of economic, political, culture, and social development. Actually, it put ecological civilization, I mean, in a very high position. Then how to promote ecological civilization? Here is some of our understanding. If we look at ecological civilization as a building, then what we need to do is to promote and to make ecological civilization from three major aspects. Then like a building, then we need to have beam, then we need to have pillars. So the one beam of ecological civilization is, sorry, there's no, here. Oh, no laser, right? Yeah, the one beam is we call then we have two pillars. One pillar is we call the low carbon development. Another is circular economy or circular development. And also for circular development, actually there are many of the work we have to do, like the institutional reforms, the industrial development, technological innovation, business modes, and green living, so on and so forth. Then for digitalization and digital technology, we think that's a very important driver for the ecological civilization and for the green transition in China. So many of them, I think we are a supporting system in this area. So that's some of our understanding about this ecological civilization and its relationship to the digitalization. And some of the opinions from my boss, Professor Du Huanzheng, was also delivered in some of the national medias, like he was interviewed in the CCTV News, and also we wrote an article in People's Daily 10 years ago. So that's about our work, and also because this is an industrial conference, so I'd like to introduce some of the industrial, some very practical programs we are doing now. In the past 20 years, we made, I think, more than 50 such projects in collaboration with our industrial partners. This is our work in the Zhejiang province. And also we have a lot of industrial partners, and we got research fund from some of the partners like Nike and Coca-Cola. I will introduce some of the work we are doing now. Then this is the pattern of our collaboration with the industrial partners. So we call somehow the six contributions or the six things we'd like to do together, including one we call the key technology, then some of the system solutions. Then we'd like to do some demonstration projects, means could be some other project or could be, let's say, a new business company. Then also to do those things, we need human resources. Then also we need some of the funding support. So that's about our collaboration with the industrial corporations. Then we think digital technology and digital economy is very important for the green development. So we are trying to put this into six levels, namely from the country level to the regional level, city level, industrial park level, enterprise level, and personal level. Time is just too limited, so I'd like to skip this very quickly. For example, the national level, we have some comprehensive national plans and policies. I introduced a little bit already. And at the regional level, I think here a very interesting example is a program is doing now in China, we call the East Data, West Computing. Because in Western China, the area is rich in material resources and energy resources, especially the renewable energy. So we're trying to use the renewable, the greener energy and electricity in Western China and to compute the data generated and needed by the Eastern, because in Eastern we are more somehow a higher maybe economic development level and more people living in the Eastern. And through the carbon trading system, I think both East and the West can get some benefits from this East Data West Computing program. So also at the city level and the industrial park level, the enterprise level and the personal level, we have some of the work are doing now. We are trying to apply digital technologies and to incorporate ICT and AI technologies into our work for green development and for circular and low carbon development. Part 3, I'm going to introduce our work, more practically. So I just like to introduce two cases. The first one is we call a digital reform or digitalization of the municipal waste management system in China. So we know many of the cities in China are somehow we must overcome the challenges for municipal waste each year. Some 240 million tons of waste generated in many of the cities in China. And from the top 10 cities, there are some 60 million tons of municipal waste generated per year. And from 27, then China is trying to promote the waste sorting for household and municipal waste. And in this new progress, actually we have a lot of digital technology applications throughout the whole process of municipal waste management. So from the beginning side, for the waste generation part, we have, for example, some interest in we call the smart sorting machines to help the people to sort waste more easily. And at the transportation, the collection phase, then we have some, we call the intelligent transportation system and so on and so forth. And also for the waste management and the recycling, we also incorporate IT and DT into this area. So I'm going to introduce later. This example developed by BEG. BEG, Beijing Enterprise Group, is actually one of the leaders for we call environmental services for water treatment and for wastewater and also for municipal waste management. And BECS, Beijing Enterprise City Service, is actually a sub-company of BEG Group. They develop a system, a platform they call the City Keeper. That's a software mainly, but also there are a lot of, hardware technologies can be incorporated into this system and to help a city or maybe a small area of the city to manage, to monitor their municipal waste flows with better efficiency of recycling and management. And my boss, Professor Du, is actually in the director board of BEG. He's actually an independent director for the BEG. So we have some collaboration with BEG for the City Keeper development. And also we have some other innovations. For example, the first one is sweeping robots developed by the BEG group. And second one is the photo on the right is actually a smart sorting, we call it maybe the garbage bins or smart sorting machines. Then for each type of the waste should be delivered into different boxes in this machine. Then also we develop another machine is for sorting for waste plastics, especially the PET. So they can separate different type of waste plastics automatically and with a very high efficiency. So some of the videos I'd like to skip. And for the education, because I'm from the university, so we are doing some education work. We worked with some of the companies in Guangdong province. Then we developed some digital education plan for municipal waste management and for sorting, and to help the people how to circulate and how to reuse different materials and to do a better waste sorting. One of the work is we call iCircular Lab. Actually, we are promoting the lab in some of the elementary schools and the high schools in China. Then the second case study, I must close my talk very quickly. That's about we call closed loop recycling of sneakers. This work is supported by Nike. We are working together with Nike to recycle used sneakers, and we try to convert the materials from used sneakers into some very interesting products. And our final goal is we want to use the used sneakers to make the new sneakers. So that's a video, I think, just very quickly. So some of, the rubbers we recycled. Yeah, then we have to recycle this. Then there's some of the technologies called the Nike brand we are developing, we are working together. Yeah, so how to skip this very quickly? That's our collaboration with Nike. Actually, our cooperation started from 2021. Then almost, 4 years have passed. Then we have made some interesting products and some interesting progress. So I'd like to introduce to you. So first, there are some of the products we made with recycled materials from used sneakers, from shoes. For example, the ball, then there's some notebook, then also some sports goods. This is the technical progress of recycling. I think I'd like to introduce a little bit. Actually, when a shoe comes in, then we have a separation line. We use robotics to separate the upper from the sole. Then for the upper material, it's mainly chemical fibers. Then we develop some chemical method we call RBHET progress technology to recycle the chemical fibers of the upper material. Then for the sole, it's mainly rubber plus plastics. Then we have also some of the technology development in this area. Then this is for polyester, the fiber recycling. Then from the fibers and to the final products, that's RBHET powder, and this powder can be used to make fiber again. Then for the rubber, we have some technology to grinding, to break up, and to molding the rubber again, and finally they can become, for example, the tracks or the floor matches. Yeah. Then for the digital technologies, it can be applied all through the progresses. For example, at the collection phase, we work with Ant Group and Alibaba to recycle used shoes. Very often used app by Chinese is Alipay. Actually, in the Alipay system, we develop an app we call the Move to Zero, or the reverse of used shoes. Means people, they just use their cell phones. If they have some used shoes like to be recycled, they can just put an order, and we will come up and we will take the used shoes away, then back to the recycling system. That's what we are doing now. And the second part here in the middle is actually a separation line we developed, and here we use, for example, visual recognition. We use the AI technology to identify the shoes. Because currently this is developed for sneakers only, not for other shoes. So we need to separate other shoes from sneakers. And also there's robots, they can separate the upper and the sole. Yeah, so that's some of the technologies. So I think my time is almost up, so I'd like to skip very quickly. This is probably the final slides. I mean, our work is not only, environmental friendly. Actually, we are also trying to do some things, good for social, especially Nike. They put social responsibility at their priority tasks. So, for example, for the shoes, the sole we recycle, it's mainly rubber. So we use this rubber to make, for example, the running tracks, the playgrounds in many, schools in, the local areas in China. So I think this program is actually a contribution. Not only to environment conservation, resource recycling. It's not only an application of digital technology. It's also, can help, for example, the low-income children to make them like sports. So that's this work. So some of other technologies, and also we develop standards for the recycling and for the carbon footprint for recycled sneakers. So that's all. Thank you very much.
Thank you very much, Professor Professor Wang Tao, for your insightful keynote and for setting the stage for today's discussions on convergence of digital and green transition. He highlighted us the importance of ecological civilization, green circular, low carbon development, and digitalization for urban development. Thanks very much again for his very impactful talk on circular value creation and the importance of recycling, especially these Nike sneakers. And today, once more, he highlighted the importance of including society with their Move to Zero project. Congratulations for it. Now, I would like to invite Professor Lloyd Tonley from Nanjing Smart Technology Development, China. He will present advancement in digital water management, highlighting technologies that enhance efficiency and sustainability in water resources. Please, Professor Lloyd, floor is yours.
你们好，大家下午好。我住在南京. I can speak a little Chinese, but I won't. I also need to go very fast. I have many slides. You see, I swapped the order of digital and green. If you look carefully at the agenda, we have digital, green, green, digital. Anyway, all together, I will talk about water, and I will talk about technology and digital and green. Not that one. 5 headings. I'll talk about digital and green, about water management, and in particular you'll see that I'm talking about water resource recovery, or what we used to call wastewater treatment. This is the island in the middle of the river. I used to work here. I can't afford to now. Water management, I've worked in the mining industry for 30 or 40 years, and sometimes we simplify water management to these 3 headings. Too little, too much, or too dirty. And actually, if you look at the history of how societies for thousands of years have dealt with water, we always need water supply for drinking and for agriculture. We have to manage floods, that's the too much. And if the water is dirty, we need to treat it in some way, or manage or protect it. You know, I won't go back thousands of years. Organisations like IWA and IHR, there are teams of people looking at how ancient civilizations managed water. But let's say in the last 100, 150 years, the job of managing water was initially the job of civil engineers. And later, at least when it came to managing dirty water, we coined the term sanitary engineering. Today, the word environmental engineering is used largely for that part of engineering dealing with dirty water and wastewater treatment, or, as we've been trying to call it for more than 10 years now, water resource recovery. Let me talk about digital and green. The green movement. You know, I think we all have a feeling for what it is to be green. Actually, thousands of years ago, in Rome or in China, people understood about the environment. In the 1800s in the US, there were movements to form national parks, also in Europe. The first Green Party was in New Zealand in 1972, so let's say 50 years. But green is in some sense good, and that's what I think we're all trying to do, is something good for the environment. Digitalization, it's maybe started 50 to 70 years ago, and there are so many buzzwords. Digitalization seems to be one of the latest. I've never been comfortable with buzzwords, but actually if you can't beat them, join them. We kind of have to use the term. The digital revolution. In fact, even today or last night, the International Water Association, which I work with closely, they had a meeting, are having a meeting now in Bilbao on digital water. And I won't talk about their work, but for days people talking about digital water. SDGs. I think we were encouraged coming to this meeting to think about our work in the context of the UN Sustainable Development Goals. Often we see a grid with 17 coloured squares. This is another view that actually puts water down at the bottom. It's the blue one on the right down the bottom, number 6, clean water and sanitation. There are journals full of papers with figures like the one at the right. Everything is interconnected. That's fine. I want to focus on the two at the bottom, the connection between clean water or cleaning water and climate. So that's really the focus of what I'll talk about. Yeah, I've been around for a few years. I started programming 50 years ago, more than 50 years ago, and I've written a lot of software. For me, that was already digitalization. We were using software for many things. And along the way, I've worked in the mining industry. In the mining industry, we have SCADA. We have instruments for measuring flows of water and water quality and temperature and pressure. You know, today the buzzword might be IoT, Internet of Things. The idea that you can have a sensor everywhere with enormous amounts of data that become big data that is somehow processed by artificial intelligence. If I had enough years left, maybe another 50, then I would focus on improving water resource recovery to reduce greenhouse gas emissions. So that's the connection I want to make between water resource recovery and climate change. So the numbers here, we can argue about the numbers, but I've seen an estimate of 109,000 water resource recovery facilities globally. In China, maybe 15,000. When we use energy, particularly in mixing and in aeration, we use energy from another location, but often that energy is from burning coal or gas or oil, and it releases CO2. So water resource recovery is a source of CO2 emissions. Especially when we have the solid waste in anaerobic digestion, we also release methane. Methane is 28 CO2 equivalents. In the process of nitrification and denitrification in normal biological treatment processes, there are a couple of pathways that release nitrous oxide, N2O, laughing gas. This is 273 CO2 equivalents. It's much worse. It's a smaller quantity, but it's very significant. I've previously seen estimates that the wastewater treatment world is responsible for as high as 3 or 4% of global greenhouse gas emissions. I've checked with a friend, actually an Australian woman living in Scotland. She works for Jacobs. She's becoming a world leader, very vocal in this field. She thinks the better estimate is 2%, so let's work with that. 2% is a lot. If we could make a big difference with this 2%, it would be a big contribution to reducing greenhouse gas emissions. And I just read before the session that the numbers came out yesterday. Last year we went up by another 0.3% in CO2 emissions. For 2024, that's an estimate for 2024. Now actually it's well known that we can reduce emissions in aeration by 30%. That's quite common. So actually if you multiply the 0.3 by 0.02, if we could improve all the operations around the world, we could save 0.6%. I mean, we must make efforts to make a difference. So when I came to China 7 years ago, I was challenged to work on water quality in river basins and improving performance of plants. Actually, I see now that working on water resource recovery is a way of doing both, and also tackling the greenhouse gas emissions issue. Now, what I see when I look at research in universities, internationally to some extent, and especially in China, is that because university professors and their students, they chase papers in journals. So you look for a plant which has a different type of water, which needs a different process, and then you can write a paper. But actually, about 60% of all plants are of 3 types. I'd like to look differently. I'd like to look at the very large number of plants and find the common elements. Try to figure out what we could do that goes halfway. Don't look for the perfect solution at one plant, but look for a partial solution at many, many plants. That way, we have more chance of reducing greenhouse gas emissions. It's a simple strategy, or concept. I don't see anyone doing it. So I choose that. I refer down here, big, hairy, audacious goal. It's a term that comes from the book at the right. When I heard that term 30 years ago, I didn't like it very much. But that's actually what we need is, let's just say, big, audacious goals. Difficult goals. Otherwise, we won't reach targets. So let me talk just a little bit. I'll go fast here. I think we know, and a couple of speakers after me, Professor Murray is talking about different order, food, energy, water. But these are good concepts. What does it mean in, how does water resource recovery fit in this? It's a little hard to point, but we have food coming into our house. It becomes municipal wastewater. When we treat it, we have solid waste which can be returned to agriculture. That's resource recovery. And the liquid waste, when it's treated, goes back to the rivers. It can cause algal blooms. It can be treated for drinking water. Anyway, there are a couple of cycles here. That's how water resource or solid and water resource recovery fits, and it uses energy. And the energy releases greenhouse gases of different kinds. When I think about a lot of engineering works related to water, there are always two parts. One is the infrastructure. And in China, people love to sell you something new. Sell you the new infrastructure because you have to pay a lot of money, I can make a lot of profit. But actually, almost more important is the operating rules. And that's what I like to focus on. I think it's more important. I would rather focus on improving the operating rules for existing plants rather than building a whole lot of new plants. First of all, too expensive, we can't afford it, and uses a lot of resources. That's what I think we should be doing. I'll skip this. This is a flow sheet for a classical plant, and just show some pictures. These plants are big. I referred to aeration. You can see the bubbles on the top surface here. That's from air bubbling up to initiate the nitrification process. And these are bubblers on the bottom that release the air and pumps. You can see a lot of equipment, but how do you operate it? What are the operating rules? Many types of aerators. So actually, the primary controls when we operate a plant are changing the way that we recirculate the water, because we send water round and round. And this is a variable. It's a control. We could change this rate. Of course, if you pump less, you save energy, reduce CO2. You can see in the top right, CO2 emissions come from the aerators and from the pumps. We can reduce carbon source. Sometimes you have to add chemicals with carbon in order to keep the bacteria growing. Anyway, if we could figure out how to control all these things well, it's kind of win-win-win-win-win. We can improve or maintain the quality of the effluent, reduce the emissions of CO2, reduce emissions of methane and nitrous oxide, reduce operating cost, and actually for big plants, the payback period of this investment is 2 or 3 years. That's been shown. Now, there aren't so many examples. I'll just talk a little now about digital twins. This is another buzzword. In fact, my friend Wim from Belgium, who was talking last night, he said that if you look at citations now, digital twins, everyone's talking about it, but not this kind of digital twin. In China, Pingtai, everybody must have Pingtai, a platform mostly like the picture that we saw earlier. Mostly it's many computer screens showing data. What we're talking about is prediction, model predictive control to introduce to many, many plants. So look, there are a lot of words here. I'll show another picture. This is a paper that we wrote a couple of years ago. I'm involved with a committee of the International Water Association. It's called Modelling and Integrated Assessment. I think our group is one of the most active groups in the world, trying to find a way forwards here. What is a digital twin? Well, in our world, by our definition, and in the paper that I just showed you, you must have a real system, and then the rest of it is soft. It's in the computer. That's the twin. The twin is a virtual twin, but the two of them must talk to each other. So you must have measurements from the real system going to the soft system. The soft system must be capable of making recommendations, not necessarily fully automatic, but providing a decision support system. That would be old terminology. Providing support for the operator. That's what most of the Pingtai I see in China, they don't really do that. For us in our IWA MIA world, that's what we mean by a digital twin. So actually there's a lot of science and technology required. I just refer here to lots of the sciences and types of engineering required to make this work. Perhaps that's why we're not doing it yet. But I said I wanted to have a big, audacious goal. We must find ways to have collaboration, to have teams of people working together to find a simple way to have some savings. Not a perfect solution for every plant, but a partial solution that is easier to implement for many plants. There are many types of models. You may have heard of hybrid modelling. That is the way of the future. That's what we're recommending now. It's a blend of physics-based or mechanistic models and all of the AI stuff, which doesn't work on its own. We know it doesn't work. We know it won't work on its own. Real-world examples of digital twins, actually, I said you can count on two hands. Well, there are 6 papers. That's one hand and one finger. So if you look, it's only in the last few years. The best paper is the last one. It's quite a recent paper. I know all but 2 of the authors. 5, 6 of them are on the committee that I'm on with IWA. And this is a very good case study at a plant, Eindhoven in Holland. And what's really interesting about it is that kind of the plant is in Holland. The brains, the people driving the concept and the methodology are in Belgium, in Ghent. And the software is in Copenhagen, in Denmark. This is 3 countries working together to have a real-time digital twin that is now full scale, but one, you know. And the other one at the top, I think, no, 3rd one down, Changi in Singapore, is also a good example. I think they started commissioning middle of last year. Now, collaboration, okay, we've heard today about the need to include people from the community and people of all kinds. So yes, they can be involved in the universities and in the technical institutes, the kind of institutes that work in WAITRO. We need many people of many types to work together. I want to start by asking, how do you design and build and operate water resource recovery facilities? Well, because it's the world of water and municipal water, often the money comes from government, and especially in China, I put some of these words in, things are driven by policies in China and funding. The term Design Institute is also targeted to China. There are special institutes that have the qualifications to do the design. But this is the system, if you like, the establishment. The people in the past, that's how they do it, and they develop the new water resource recovery facility that does 2 things. It produces, hopefully, clean effluent and also releases greenhouse gas emissions. But actually there should be a role for the institutes, the scientists, engineers of many kinds, and other service providers, by which I mean consultants, in different forms, who I think have the potential to improve operating rules. Because most of the rest, the existing suppliers, they want to sell you a new system. And I think we don't have the time or the money. We really should be focused on improving the operating rules. This question of technology push, I suppose if I had the technology, I would like to encourage or push the technology. We don't yet have the market pull for this. And I'm certainly finding that in China. Nobody is asking me to help them to reduce greenhouse gas emissions. And by the way, that's partly because I'm a foreigner. I can't change that. But as a foreigner here in China, they won't ask me. There are some Chinese who are asked, and I would love to work with them. Again, I just drew this little map showing how many different schools at my university could or should collaborate together in order to tackle this problem. Here I refer to the IWA group that I work with. The Water Environment Federation in the US, WEF, is a huge organisation, many, many members, and they were very active. Now I think MIA is a little bit more active, and then some of the very good consulting firms are in the US. But it is also interesting how few universities there are around the world who are really the experts in this area. Look, innovation ecosystem, these are all good words. Yes, we need to work together. Down the bottom, I say, we need a lot of people to do this. But with this big, audacious goal, if we are to make a difference in an area that is responsible for 2% of greenhouse gas emissions, we need to train more people. So this is my last slide. We have to go faster. The digital transformation needs to go faster. And I believe that rather than the perfect solution for a few plants, we should find simple halfway solutions for many, many plants. The good thing about this whole digital twin thing is that it actually can pay for itself, but we need some really good examples quickly, and we need people. It does depend on people. It's not just technology. That's enough. Thank you. Okay.
Thank you, Professor Tonley, for highlighting how digital innovations are driving efficiency and sustainability in water management. He emphasized and highlighted the importance of carbon emission reduction in water resource recovery, and it was really impressive to me to see that the improved operations could actually reduce carbon emissions by 30%. It's really impressive. And once more, thanks very much for highlighting the importance of collaboration and co-creation because of this global issue, water treatment issue. Thanks very much highlighting the importance of industry, university collaboration and co-creation. Now let's move on. We turn to Dr. Himesh. Are we ready? I hope I spelled it correct. From WAITRO Technological Center, Spain, and he will explore digital innovations in hydrogen production, showcasing how technology optimizes processes for renewable energy sources. Thank you, Doctor. Please, the floor is yours. Thanks.
Thank you, Dr. Salik. Good afternoon. I'm Himesh. Are we ready? I currently lead digital and mobility area at WAITRO. WAITRO is a private research center from Spain. We're currently operating in 10 different locations. We're founded in 1906, so we are more than 100 years old. Back in the time, we used to do work on textiles. But in the 21st century, we diversify our assets and interests into different areas. That includes healthcare, medcare, logistics, security, transportation, and energy storages, including batteries and hydrogen. Currently, we are running operations of hydrogen in 3 different asset zones in and around Barcelona. We're also actively involved in many international associations and platforms. In WAITRO, we're currently the focal point in Europe, and we're also leading the task force at the European level for Horizon Europe proposals. We're also very actively involved at the Inter-American Development Bank, We're also working very closely with the Commission in European funding programs. We are the third most funded partner in Spain, and we're also working with World Bank. We've been working with many technology centers and projects in and around the world. So far, we have developed projects with more than 2,000 partners over 70 countries, and we have created strategic alliances with many key players around the world, and some of them are part of WAITRO as well. Bit about hydrogen projects in WAITRO. Among several of them, one of them is Vivaldi. This is European funded projects where we are creating a bioreactor or bioelectrochemical reactor where we are using the nitrogen or nitrogen compounds in the wastewater treatment. And we are using that as a fertilizer, and we're using that to resolve hydrogen. In this case, we are producing hydrogen on several components of the reactor. From the side of LATAT, we have developed new type of membranes which can efficiently separate the molecules of hydrogen from the nitrate or nitrogenous compounds in the wastewater. We have also European funded project like Robinson. In this case, we combine the same bioelectrochemical reactor with anaerobic digestion. In this case, also we produce hydrogen on the cathode side, but in this case, we also had microorganisms. Another project is funded by the European Commission in the part of Clean Hydrogen Framework, where we do not use membrane at all, and we compress at very high pressure, but at moderate temperatures, and we reach the water at a supercritical temperature. This is extremely innovative technologies which can further reduce the cost of not using the costly components like membranes, the control systems allocated for the membranes, and so on. In this case, we can also use the heat derived from several industries and decarbonize industries and creating a circular loop and producing the hydrogen at the same time. We're also very actively involved with the Spanish funded projects. There is Regenera, which is also using one of the novel membranes, but a bit of a different class, where we also are using the bioelectrochemical reactor, but in this case, we combine carbon dioxide and methane in order to produce hydrogen. We've been also able to produce not only proof of concept, but also pilots. These are some of few examples of what we work on hydrogen projects at LATAT. But moving away towards digitalization, we face many challenges, and this is what I want to really focus today. One of the main challenges we focus, there are too many technologies on hydrogen, just like with the previous projects, also in the market. So how do we work with so many hydrogen production technologies, and how do we digitalize that? Most importantly, the basic step, how do we collect the data? And this is a very big technical problem. Second is that how do we train our researchers, our colleagues, to move from green technologies to have green and digital technologies? Not only researchers, but also innovation managers, business developers. This is a management problem. Last but not least, and the most important one, is that how do we teach industries, how do we motivate industries and the stakeholders at the local level, at the regional level? And this is quite an important challenge, both at industry and the policy level. So we had all these challenges and we don't know how to solve them. A few years ago, we started talking at the regional level with different research centers. During the discussion, we noticed that there are several technologies we can complement with each other, and we created a project which we applied to a Spanish regional funding, and it is called Henry, and this is coordinated by Ciudad. In this project, we joined forces with 5 research centers in order to tackle these challenges. And the aim was to look at 3 major technologies. One based on solid oxide technologies, which is quite at the moment between proof of concept and pilot in some countries at pre-industrialization level. Second, photoelectrochemical storage technologies, basically using the sun and producing hydrogen directly. So this is a very novel technology. Still, there are proof of concept, but no industry solution yet. Third is a dark fermentation technology. So we try to solve the desalination using these key technologies, and we decided to develop a digital toolbox. Because the project is so big, this is still an ongoing work, and I hope some of the key lessons I will show you here might be useful to you as well. In the first phase of the project, we focused on development of the technologies. We were able to produce large-scale production of ceramic membranes using electrospinning. For the purpose of desalination, we decided to use only 1 kilowatt system, although we have targets to go up to 100 kilowatt system. We have used several simulation models. We have also used several computational fluid dynamic analysis and other simulation analysis to understand the interaction of such ceramic membranes with operation conditions. In the second technologies, the photoelectrochemical one, where you basically use sunlight to produce hydrogen, we created a novel membrane. Not only that, we also developed our own cell where we want to understand how the materials degrade over time. And we also collected this information during the operation of the cell. And that has been a key to understand the degradation mechanisms in these kind of technologies. On the third technologies, since we've been working for quite a number of time, we actually went a step ahead and created a platform where we collected all the data and information. On the phase 2, we also wanted to interact with industries. At the early stages of the project, we created a survey model. In this case, we created a scope of what kind of data industry is interested, what kind of hydrogen technologies they are interested, and the priority from their side for the commercialization. We also looked at self-development model because some of the industry partner was wondering if this model can be tuned. We also looked at the programming environment which industry is comfortable with. We also looked at key variables which industry players were interested, and then how industry players want the data to be delivered. And of course, how many users in the industry are interested in using the platform. Of course, this is an iterative process and we're still developing and updating this survey model. On the phase 3, but before going to the phase 3, we also organized key webinar sessions with industry players where we gave information about what are the base technologies available, what are the key technologies which needs further development or investment or ready to market. And in this case, we organized several webinars with key partners being invited in these consortium meetings. In the phase 3, we had the data collected, so we created a basic architecture model of this digital toolbox. Since we had these three technologies on the development phase, we were not able to do diagnostics and fault analysis. And because of that, we were missing that component. So we did a bit of an iteration. We redid the architecture and brought in two commercial technologies, proton exchange membrane and also alkaline-based electrolyzers. In this case, we added another layer of commercially available type of electrolyzers and tried to detect the fault and diagnostic systems. Within this framework, a basic framework, we created APIs, keeping in mind to have open APIs to monitor key performance metrics, status of different components, different type of electrolyzers, and how they are behaving over time. We brought in all the 5 actors, but on the background, we had comments coming from industry players as well. And we tried to iterate the interaction of such an architecture system. We created human-machine interface within the SCADA system, and then this human-machine interface allowed the operators, engineers, and researchers to interact with all the simulation environment. We also created easy to customize dashboards, process flow diagrams, and also visualize the whole hydrogen production process, getting the feedback from the industry, from the survey tool we previously had, which helped us to monitor the hydrogen production processes, adjust the data in the real-time processes, and receive alerts. Some of the alerts we were focusing was on the faults, when the system is detecting the faults and where the system needs to stop before going further iteration. We also created diagnostic tools using the baseline of PEM and alkaline electrolyzer, and we fed into the system as a pre-model or pre-simulation model. This is still ongoing work, and we are still iterating this architecture. Then we created a database. On a basic database, we recorded all the data coming from the production data, diagnostic data, simulation of the future reference samples. We allowed the SCADA system and the API to access this stored data as well, in order to make a real-time decision making as well. And we created an export tool. Several industry players wanted the data just in Excel. So in this case, we only put in Excel. But in the future, this can be also adaptable with the interfaces which the software they're using. We were missing how to control and adjust the capabilities of such data sets. In this case, we created an interface with external data sources. Since our API were open, we were able to also work with open databases easily, where we work with Iberian electricity market operator, which was focused on the region in Spain and Portugal. We also were working with photovoltaic geographical information system. This is a platform funded from the European Commission, from the Joint Research Center. And we constantly updated the whole architecture. So such architecture can help you to develop integration of different technologies. Going back to the management problem, how do we train researchers or innovation manager? To improve that, we created a bootcamp training for innovation managers, focused on understanding what are the funding opportunities available in hydrogen technologies and in which TRL level. We went on focusing on European financing program for starters, where we focused on the proof of concept projects. If you are coming from Europe, you probably are aware about it. There are funding programs available like Horizon Europe, which focuses on TRL 3 to TRL 6, which is presenting the prototype. we also focus on projects which are going beyond demo cases and how research centers can participate in this kind of programs. We focus specifically on innovation fund. This is coming from carbon offset trading, a budget which Commission has. Every year there is around 3 to 4 billion euros dedicated for that. We also focus on inter-regional network programs and saw what are the funding opportunities and how RTOs can use their digitalization background for that. In the next upcoming week, we're also presenting and interacting with different stakeholders in the industry. We are constantly updating the survey to collect what kind of data is industry interested, what kind of data they are willing to receive after the simulations are done. And we will present this project and also update our survey model. If you are interested, I would recommend to attend one of these sessions. This is quite interesting because there's more than 70 European funded projects on hydrogen presented there. Interaction with stakeholders was really difficult in this project. However, we had a good opportunity because this project was partially or most of it was funded from the regional government, which is coming through CDTI funds. In this case, we had an open dialogue with them and tried to understand where industry can use their financing projects. And we created a tailor-made info day call where we selected key calls where industries can go and apply for digitalization in the hydrogen technologies. We had Clean Energy Transition Partnership, we had Eureka program and also Innovation Fund. We had also Clean Hydrogen Partnership and with the help of Spanish technology platform. This is still an ongoing discussion and we have already planned to do this event in February. Not only giving information to industry or teaching industry what are the digitalization options available for them, but we also want to monetize on that. So in the same program, we're also planning to do matchmaking, creating an interaction, an open dialogue between RTOs, academic institutions, and also industry players, where we have identified already more than 20 European national funded programs, and we are already doing capacity building among this. So we saw going from green to green and digital solutions, some key challenges. In the technical challenges, we were able to define different survey tools and digitalization tool which can able to serve and solve these issues. We saw management issues. In this case, we looked into designing boot camps, training sessions for innovation managers, and there are upcoming sessions from researchers. And then the stakeholder industry issues. We opened dialogues and survey tools with industry players and the regional and the local government in order to solve that, and attending several B2B events, info days with the local and regional players. I hope that such a methodology might be also useful at the international level. And if you have a better way to solve such an issue, please do let me know. Maybe we can make a project together in the future. In that case, do not forget to write to me. I'm available on hemeshavredi@leita.org. Thank you.
Thank you, Dr. Avi Reddy, for sharing your work on optimizing hydrogen production, a key area in our transition to clean energy. Also showing the possibility of funding on hydrogen technologies. We are close collaboration between CDTI, as you know, with TÜBİTAK bilaterally and multilaterally through Eureka programs. And it was very interesting talk on hydrogen technologies, from solid oxide technologies photoelectrolytes to electroformation platform, together with data collection and architecture development, which also show the importance of open data and open science, I think. Many thanks for sharing these case studies, and at this point I'm pleased to welcome Professor Henry Jean Maraish from Northwest University, South Africa. He will delve into the role of digitalization and AI in managing the complex interconnections within water, energy, food nexus. Thank you.
Good afternoon, everybody. Thanks for attending. Today I'll speak a bit about how digitalization is impacting water, energy and food, specifically focused then on the food aspect of the nexus. A few talking points, some introduction, focus at food, looking at what happens when you try and scale these technologies, and finally wrapping up with the opportunities for impact. Now, if we look at the water, energy and food nexus, and it's a common concept, but essentially what it boils down to is that food production affects water use affects food production. Similar things happen with water and energy. You will probably be able to put additional industries on that map to have interactions. And then between energy and food, there's also an interaction. Right? So you need energy in the form of let's say electricity or diesel to produce food. You can, however, from food also produce energy if you look at biofuels, production of ethanol, and that sort of thing. Now, obviously, with this, there comes a whole lot of issues. Particularly important is when looking at food production. Now, the figure on the screen sort of shows you a map of the world, roughly categorized in terms of agricultural yield per land mass in dollar terms. So I'm from South Africa, so right at the tip of Africa, and you'll notice that it's relatively green but not super dark. South America, Latin America specifically, the US and China produces by far the most agricultural products by value. So this is not too bad. Africa looks like it's doing okay. And then if we overlay that with the potential impact of climate change, the story is pretty bleak. So we find that Africa, Russia, China, and South America are disproportionately affected by climate change. So that leaves us with a little bit of a problem in the sense that in this map, most of our agricultural yield will now be severely affected by climate change. So we need to find ways to deal with systems sustainability issues, integrate the management of resource consumption and planning, optimize resource usage, that includes water resources amongst others, and obviously the management of consumption systems. So as an engineer, that to my mind would be something like demand side management, but you won't really make people eat less food. So we need to find a way to deal with this sort of impending issue of a threat to our food production systems. Okay, so when looking at population growth, this estimates, now we can fight about the numbers all we like, but it seems like Africa is expecting a population boom, almost a doubling in population size expected by 2050. Similar kind of figures over the rest of the affected areas. So we have a major problem on our hands. And this got me thinking in terms of maybe there's a better way. However, if we look at food in terms of a sustainability perspective, 1 billion ton of it is lost every year. So we spend a lot of resources producing food that we simply can't even access. And there's various reasons for that. Sometimes it's the supply chain, sometimes it's overproduction. So on the one hand, it's this overproduction problem, so we can't manage the demand well, can't estimate it well. A quarter of fresh water is used in agriculture, so by definition then we waste 25% of fresh water. Africa is pretty water scarce, particularly sub-Saharan Africa, so wasting 25% of a precious resource just does not really make sense to me. A quarter of all fertilizer in the world is used in agriculture, and agriculture consumes a land mass greater than the area of China. So if you count up all the plots of land in the world, it's quite a big piece of land. 8 to 10% of greenhouse gases comes from agriculture. So by virtue of Prof. Townley's assessment earlier, if we can just sort of sort out the 25% wastage, we make a 25% change in 8 to 10% of greenhouse emissions, which would not be bad. If we look at farming in general, we end up with this little scenario. Now, the map is not complete, so North America and Europe is largely excluded. But what is important from this perspective is that most of our agricultural products in the global south, and China then by extension, is produced by very small or small-holding farmers. So it's 1 hectare, very small is 1 hectare or less, small less than 2. Large farmers, according to this map, is about 15 to 50 hectares. And from the location where I'm at, 50 hectares is seen as a sort of smallish farm. So in terms of the rest of the world, small-scale farming is really, really important. So this poses interesting questions in terms of what are we doing to deal with the confluence of factors. So climate change, increasing in population, trying to get rid of this wastage, and most likely it requires some novel thinking, some new technologies. However, research seems to focus on conventional practices. So just improve what we've been doing for the last few hundred years, and that to me seems like it's short-sighted. So that's not to say that people have not tried things, right? So modern agricultural practices like soilless agriculture have been tried, and it's been demonstrated on small scales. So on screen you'll notice a few examples of hydroponic growing. On the left, some lettuces, some nice vertical towers. On the right, a hydroponic setup on the roof of a shopping mall in Cape Town, South Africa. So they're using urban areas, no soil in sight, very successful, but pretty small scale. And in the middle, there's a sort of system that a farmer put together himself, and he's growing some plants with varying degrees of success. And varying degrees of success certainly won't cut it. So how can we use digitalization and the associated technologies to scale these systems? Okay. Research have identified primarily 6 areas of improvement, and I've highlighted in purple blocks a few of the important aspects. So primarily being services towards a group of farmers to try and leverage this group of small-holding farmers to access better markets, be more competitive, and be able to put a better value offering in the market. Inexpensive sensors and IoT, so that connects to the data problem that Hamesh highlighted earlier, that we need to know what are these things doing so that we can sort of leverage that information. And then obviously alerts to the farmers and the greenhouses and that sort of thing. So telling the farmer that something is going wrong. We must remember that many of these smallholder farmers are traditional dry land farmers. So it means you plow the soil, plant your crop and wait for rains. New technology brings with it the added problem that you don't have generational knowledge in terms of how does this work. So we need to find a way to manage that. Robotic systems and greenhouses, they go hand in hand, although in Africa in particular, we'll have to be very cautious of replacing manual labor with robotics due to high levels of unemployment already. Yield monitoring connects more or less to those IoT and sensor aspects. And then irrigation scheduling, water stress prediction, and monitoring the amount of water used seems like such a simple problem. yet it is one that receives little attention within the agricultural space, dryland farming or otherwise. And then smartphone applications are seen as a way to democratize access to information. So artificial intelligence applications will allow easier weed, pest and disease identification. We should remember that most of these farmers deal with elements visually. So if I use a smartphone, the farmer would be able to take a photograph of a plant leaf and we would be able to diagnose what the typical disease is. For sure, you can use much more expensive analytical techniques, but these farmers live in remote locations and will have limited access to resources. And then weather updates, and I think most of us in this room find that weather updates on your phone are part and parcel of your everyday life. You can quickly check the weather. But it's something that's for many smallholding farmers quite a novel scenario. And with climate change, the generational weather patterns are becoming increasingly unreliable. So some current projects that I would like to highlight from within our research group. Here is an example of the typical, let's call it African greenhouse. So you'll notice that it's not particularly high-tech, standard polycarbonate or polyethylene plastic over metal structures. The one in the middle carries a few solar panels, and then on the inside there's some hydroponic systems, but it's not heavily automated. Here's our test facility in the northwest province of Potchefstroom. So it comprises 3 greenhouse tunnels, all of them constructed in the same dimensions with slight variation between them, all of them equipped with hydroponic growth systems on the inside and pretty heavily sensorized. So we know the amount of electricity generation, water consumption, nutrient feeding profiles and all of that. And the idea is to use this testing site to be able to develop an expert in your pocket. So if you were to be a smallholding farmer and you would like to embrace modern farming techniques, you'll end up buying a little greenhouse, and these houses can be as small as 2 by 2 meters. So it's a really small little greenhouse. And the question then is, well, what do you do with it? So you've bought the house, put some plants in, but you don't know what the plants should behave like. You don't know what the weather conditions are. And the idea is to have hydroponic systems that's friendly in terms of infrastructure requirements. So together with a partner, there's a hydroponic system that's completely manually operated. So the farmer waters the plants daily. It's still soilless, but it is very friendly in terms of unreliable infrastructure such as electricity supply and that sort of thing. We could probably, and that's part of this project, try and find a way to automate that greenhouse, but in such a way that it runs primarily during daytime hours. Those of you that's been in the renewable space will be aware of the fact that lithium batteries are pretty expensive. So we are trying to really keep this as cost effective as possible. Sensors everywhere connected to the cloud and the farmer with their smartphone. Not necessarily AI in the cloud. So cognizant of the connectivity issues that these farmers might experience, putting most of the compute at the edge. So intermittent connectivity will be fine, but your farmer will still have the value that they can gain from that. On the other extreme, on the other end is if you assume thousands of these little greenhouses, you're essentially right back to the problem of a lot of smallholding farmers distributed, and they need to somehow cooperate. And this can be done in terms of demand prediction and yield estimation. And if you can get a lot of these farmers to work together, all of a sudden they can access markets similar to those that commercial farmers have access to. Technologies that we could use there is things like blockchain, so you've democratized the deal making and no longer defer your income to a third party. So it's much more community based. The community has control. By means of artificial intelligence, one can then sort of stagger the planting seasons to ensure that not all your greenhouses crop at the same time and that not everybody plants the same crop, which is typically a reasonable estimation of what happens currently. However, these greenhouses are good at growing plants, and your typical examples would be things like a lettuce or cucumber, tomatoes are also quite popular. But these crops are typically not high in protein, and we need some protein sources. To that end, aquaculture seems like a viable solution. In sort of West Africa, there's large aquaculture operations running in natural bodies of water, but in landlocked countries, you'll need to find a different way of growing fish. That's typically done in tanks, but the feeding of the fish in these tanks is problematic. So if you overfeed the fish, the water becomes toxic, all your fish die. If you underfeed the fish, you don't get the biomass gain that you should be getting, and you lose economic value. This device is essentially a way of being able to feed the tanks based on the estimated biomass, and the biomass is estimated from a camera suspended overhead. So the thing scales neatly from really small fingerlings all the way to harvest size. The aquaculture thing is still pretty novel, so we've not done too much work in that space, but it's also connected to this idea of having small-scale farming activities in regions where it might not be otherwise viable. So theoretically, you could put a fish farm in the middle of Nanjing, since it would be able to function there, provided that you can provide your farmer with the information that they need to run this accurately. So in conclusion then, I think there's definitely opportunity for major impact from digitalization technologies in the whole agricultural space, particularly with an eye towards future farming techniques. Yes, we would be able to apply the same techniques to existing dryland farming or pivot irrigation, but in most cases that's not the farmer that is located in most of these regions. So we need to find a way to be more inclusive, and I think digitalization is a way of doing it. So the water, energy, food nexus is critical from a sustainability perspective, not just on the food side, but also on the water side. The global south, climate change and population growth seems like there's a confluence of bad factors acting together that will pose significant challenges in the near future. 2050 sounds far away, but it's less than a generation away if you think about it. The greatest impact of these changes will be on small-scale farmers who currently do not have the technology nor the finances to deal with these challenges otherwise. There's a significant opportunity for particularly low-cost digitization, and I think we've seen massive inroads in terms of sensor cost reduction over the last 3 to 5 years. You can now have a computer that's a multiple of the one that landed on the moon in terms of computing power in your pocket for less than about $20 US. Research is primarily plant-focused for the time being, although we've made some inroads in terms of producing sustainable protein sources in the form of aquaponics and the aquaculture associated with it. More work still needs to be done in that space. Thank you very much.
Thank you very much, Professor Maresh, for emphasizing the importance of digitalization in managing our essential resources within the water, energy, food nexus, especially on food waste reduction by coordination between the farmers, novel smart aquaculture. Thank you very much for your talk. Now we will move to 30-minute break, and we will resume with presentations afterward. Please hold any questions for our panel session at the end, where we will have an in-depth discussion. Thank you. Yeah, after this great coffee break, welcome back again, everyone. We are glad to have you with us as we continue with the next set of presentations. Now, I would like to give the floor to Professor Thomas Rosenbach from Fraunhofer Institute of Optronics, System Technologies and Image Exploitation, Applied System Technology, Germany. He will present on Germany's energy transformation plans, focusing on green technology and sustainable energy strategies.
Good afternoon, ladies and gentlemen. Thank you for the kind introduction, Professor Celik. Yes, I want to focus in my presentation of the energy transformation plans of Germany. Especially, I would focus on the energy and infrastructure analysis and the derived decisions. So, oh, sorry, that was the wrong direction. Oh, I have to go back to the first, sorry. So the outline of my presentation is as follows. After a short motivation about the German perspective, I want to present you a concept that we developed to support the energy transformation, especially for regions, for municipalities, and also for companies. And then I will give some information about 3 reference projects, and finally I will give a short summary. Yes, from the EU we have the goal that we want to be climate neutral in Europe by 2050, and there are 2 milestones on this way. The first one is in 2030, so there's the target of 55% less emissions in comparison to 1990. And the second milestone is by 2040, 90% less emissions. And for this, the European Union gives a lot of funding. So for instance, the Just Transition Fund to support regions on the way to the green economy, also the Social Climate Fund, for instance. And it's worth to mention that 40% of the next generation EU funds goes to the climate actions. And so there are some regulation frameworks like putting a price on the carbon and also the carbon border adjustment mechanism from the EU. In Germany, we have a little bit more ambitious goal than the EU. That means we want to be get to greenhouse neutrality by 2045, and we have also 2 milestones, one in 2030. Here we want to reach at least 65% reducing the emissions, and by 2040 the reduction of the greenhouse gas emissions by at least 88%. So the goals motivated by the regulations from the EU and from the German government not only include environmental protection, they also promote emission neutral production. And we have to ensure this is in line with the social responsibility and also with the sustainability, of course. And so we developed a way that we say we can support regions, cities and companies how to find the best way for this transformation. And that means we will analyze the used energy in this region, in these companies, and the associated infrastructure, and then put a simulation system, and based on the simulation we can evaluate different scenarios for the idle energy supply, and this should be the basis for the measures for the transformation and the resulting investment decisions at the end. So this is a big question for all the stakeholders: what is the best way for a green transmission? And here I will go step by step through this concept, what we developed. And we already hear today in some of the presentations, databases is the fundamental thing for all these things we do in this field. And so also we want and we have to prepare a data management in the simulation environment so that we can collect all the data necessary to simulate energy scenarios of the future. And we have to make sure that we get the data from the regions, from the municipalities, from the companies, but also all other necessary data and collect in a database so that we can process the data later on. The second step is the energy flow analysis. This is very important that we visualize the energy flows so that we can data mine what kind of energy flows are the most important in the model region, and we should also data mine the energy recovery potential, because that's very important for green transformation. So if we did this, then we can come to the third step. This is the potential analysis. So that means we have to investigate the potential for the renewable energies, for instance PV, solar thermal energy, geothermal energy, and of course also the waste heat utilization. So we also want to address the potential assessment of media change. That means changing between the media's electrical power, heating power, and so on. And also, especially for companies, it's very important to have a look at the carbon capture and utilization. So this could be an important part in the green transformation for companies. So, and then a very important part of this concept should be done, and this is the technology and market analysis. That means we have to analyze what kind of technologies are available and how the markets work, and what is the function of the markets, because that's very important for the economic aspects of such a transformation. And so together with the stakeholders, we will define key performance indicators, how we can compare and evaluate different kinds of scenarios, and then we can use different kind of technologies, and also with the background of the energy market analysis, we can calculate and simulate different kind of scenarios. On the right-hand side of the slide, you can see some of such scenarios. For instance, the business as usual scenario, that means we don't change anything, but also we can look for an autarky scenario, we can look for a full electric scenario, we can also look for a hydrogen scenario. That should we do, and then we have to calculate, simulate these scenarios, and at the end we have to evaluate what is the best way for a company, for a city or for a region. Then the following step is this multi-scenario simulation that already mentioned. And here we use a software that we call EMS EDM Prophet. This is a software we developed by our own. EMS means Energy Management System, and EDM means Energy Data Management. And here on the right-hand side of this slide, you can see what we do. You can recognize the scenarios. I mentioned one slide before. Now we do the calculation, and you can see we calculate the investment costs for every scenario, we calculate operational costs for every scenario, and we make a comparison between the current scenario. And at the end, we also give an forecast after how many years the amortization time is reached for such a change in the transformation of the energy system. So, and then very important, we as engineers can calculate the scenarios, we can make all this computation tasks, but at the end we have to discuss the results with the stakeholders and have to interpret together with them what will be the best way for changing their energy system. So I already mentioned the software. This is the software we use for many years also for the energy management of different kind of utilities in Germany. You can see here some of the customers, they use our software, and we use the same software for this calculation of this energy transformation scenarios. Now I will come to the three reference projects. One project is the so-called ZORO project. ZORO means Zero Carbon Cross Energy System. And this is an energy research project with the aim of CO2-free energy supply for industrial production. And we make the simulation of Thuringia's energy system. Thuringia is one of the 16 federal states in Germany. And here we data mine what are the best or the cost optimal transfer paths to bring the industry in the new energy system. And in the following project, we did the special investigations for one part of this industry. In Thuringia, the glass industry is very important, and he's very energy intensive, you know it. And so we focus on this energy transformation path for the glass industry. And here we did not only do the calculation for the scenarios, we put also in operation an energy efficient operational management. That means we do the operational optimization for the production line with our system. And the next example is as a project for the municipality of Bielefeld. Bielefeld is a city in Germany with about 300,000 inhabitants. And the laws from Germany say in the district heating supply sector, all heating networks must be decarbonized by 2045 at least. So, and this poses a major challenge to the suppliers. So they have to decide what is the best way to make the change of the transformation of the heating system and how we can operate it in an economic way. So this is a big question, and so they have a lot of homework to do at the moment, and we can help them with this evaluation. On the right-hand side here you can see the steps we did for this utility of Bielefeld. We did the acquisition and preparation of the complete data bases. This is a huge amount of data in this case, and we put it in our system. And then in the workshop we define possible transfer paths and determine the study scenarios, and then we simulated all the scenarios. We calculated the costs, as already mentioned, and then in the workshop we discussed with this utility what are the advantages, disadvantages of every path, and now at the moment they are in the decision process what will be done until 2045 to change their heating system. And I already mentioned we want to help companies to make this green transformation of the energy system, and here we developed we derived from our Prophet software an open source software. We call it Watt Advisor, and with this open source tool you can calculate the potential to reduce the energy supply costs and the potential to reduce CO2 emissions. On the right-hand side you can see an example for a wood processing company in Germany. You can see in the upper part of this sketch the current supply structure. You can see they have some oil boilers, wood boilers, the classical energy structure for such a company. And then we defined three scenarios. One, that the energy costs in the future will reduce by 50%. It's not a very realistic scenario, I think. Then we have the current price with not change, and we have a scenario with an increasing of the energy costs by 50%. And you can see in the first scenario, the company has to do nothing at the end. He could use PV, but this helps them to save a little bit energy. But for the other scenarios, you see, they have to do a lot of more things, like to use combined heat and power. So they also have to install heat storage, and you can see the costs in the table below this sketch. And you can see they have to invest a lot of money. Also in the third scenario, where we see an increasing price by 50%, they have to invest also in some battery storage, heat storage, and this costs the most of the money. But at the end you can see the operational after 1.3 years we can we will have the amortization of the cost. So, and that helps this company very much to say, okay, we are convinced we can go in such a scenario. We don't have to close the company at the end. We can handle such prices. So, with this slide, I want to come to the summary of my talk. You see, we have a lot of challenges depending on the emission reduction goals. They are necessary, of course. We have to do the regulation compliance, so adapting to evolving regulations from EU and the national governments. That means we have a lot of data management needs. This is a challenge we have to do. We need tools for this. And then we have to see what is the best way to use renewable energy integration in the systems. And it is necessary to to make analysis of the technology and the market. They will change very fast. And then you can use the scenario simulation for prepared decision making, and you have to discuss at the end the ways they are possible for a region, for a company, or for a city with the stakeholders, and at the end they have by themselves to decide what is the best way to do the green transformation. Thank you for your attention.
Thank you, Professor Reichenbach, for providing insights into both EU's and Germany's green energy transformation efforts, showing how national strategies can support global goals. Also, one of the slides, he showed that energy and infrastructure analysis and strategy, this started with databases, which shows us the importance of data storage, protection, sharing, finding, and reminds us again once more stressing the importance of fair data principles. But I know it is not the topic of this summit. Maybe we can discuss this in another summit. Now I would like to introduce Ms. Nurul Hawaii Binti Mat Tuselim from Industrial Research Management Center of SRIM Bernat, Malaysia. She will share SRIM's approach to using digital tools for advancing green initiatives, focusing on sustainability within industrial settings. Please, floor is yours.
Okay, thank you, Doctor. Good evening, everyone. It's tough for me this hour presenting my paper. All right. Okay. I would like to introduce myself. I have to move around because I can't see the slide. All right. Okay. My name is Nurul Hawaii. I'm coming from the Smart Manufacturing Center from the SRIM Industrial Research. Okay. Okay. The content of the paper today, the first and foremost, I would like to introduce about SRIM at a glance and how we drive the ESG. ESG is environmental, social, and governance. It's a subset of the SDC to the advance of the nation. SRIM success case study and also the challenges and the opportunity. So for your information, SRIM is a premier industrial research where we are doing industrial research and also technology in Malaysia at a wholly owned by the Ministry of Finance Incorporated. We are nearly 50 years of experience in doing the research and technology development and also a national champion of quality. We are working with a vision of your partner for innovation, and also we provide the quality and the sustainability innovation. We provide not only triple helix but quintuple helix with the government, with the industry, with the society, also with academia and also environment. Okay, this is the glance of the SRIM. We have around the Malaysia, all region, we also have 4 campus of facilities, and we have 3 states office, and we also have 5 regional office, where our function and our mandate and activities are segregated into 3 different things. We are doing commercial, we are also doing development and statutory. Me myself is coming from the SRIM Industrial Research, where it comes for the development and on the research. Okay, for the SRIM Industrial Research, we are segregated into 4 different focus technology. That is the main first thing is on energy environment. The second one is more to the smart manufacturing, and the third one more to the life sciences, and the fourth one on the advanced material. We in SRIM, we work as smart. We grow our business as smart using with the tagline with ada SRIM baru beli, meaning that with the SRIM sticker you can only buy the product, right? So we are working within the SRIM matrix, and we have all these various of standard and services and security. We have the metrology, we have the assessment, the conformity assessment. We are also doing the research, and we also have the testing, training, and the technology. Okay, me myself are coming from the smart manufacturing, where we are doing starting from the precision engineering until advanced automation, innovative engineering, and also intelligent system. Our facilities is located in Sirim Bukit Jalil in Kuala Lumpur and also in Sirim Rasa, Selangor. So we have two different things focusing into the engineering, into the smart manufacturing. We embark from the Industry 4.0 journey starting 2018 in Malaysia. Right? We are focusing all these industry in Malaysia. So we help SME, we help industry in getting their innovation, technologies, and research and development. So these are our model for doing the commercialization. Starting when we do research, we are starting with the TRL1, the Technology Readiness Level 1, up into the TRL9. So we have the cooperation and competition with the industry. So meaning that we're not doing starting from the basic research. We are doing the industrial research, and we can actually collaborate with the industry or from the university or academia for the commercialization. Okay, this is what we focus is. We are in Malaysia, this is our pledge to the net zero. So with the different journey, we have several documentation for Malaysia. We have the National Energy Transition Roadmap, and even we we are in Ministry of Investment, Trade and Industry. We have our own new industrial plan to 2030. So these are our promise, where we have to go about on the renewable energy capacity and our GHG emission reduced. So our target is 2050 is our net zero emission. So how actually Sirim drive the ESG? Alright, so how? ESG stands for environmental, social and governance. So these are the subset of the SDG. So with Sirim, we have this all innovation, sustainability and quality in-house. So we're doing the all technology support, standard development, capacity building. We have the consultancy and advisory. We're doing research and development. We do testing and assessment, and also we have certification and also inspection. Here you can see all the certification level that we have in Sirim. So we are supporting on part of the implementation of SDG. So these are the levels that raised when we're doing the research, and it becomes to one of the business, so that we can increase the brand value of our product, and we have a good ESG rating, market access, stakeholder acceptance, and also the competitive advance with the global. So when we talk about circular economy and sustainable development, so these are the main things that we have to proceed. Where when we do economy, circular economy, some say 3R, some say 5R, right? So these are what we want to do. We want to reduce the environmental impact. So even the most important thing, how to start it, is to digitalization. Okay, so digitalization is the closer relationship that can help customer, mass customization, sharing and collaborative economy. These are using the technology, digital technology. So when we use the circular economy, it minimizes the pollution and waste, extend the product life cycle, enable the broad sharing and also physical natural asset. So these are one of the models that we can adapt and adopt, where when we talk about CE, when we talk about circular economy, and we also are doing product, so please look on the sustainability design. So how actually when you do this design for the product and you want to go in with the circular economy, so this will be the good model that actually combine, you adapt and adopt the CE and also the sustainability design. So from my research on the Rep Forward, I already copyright it, it's an agile requirement engineering process, where when we talk about digitalization, from digitization to digitalization and towards to digital transformation, it's not about talking about technology first. You have to change your people first, change the mindset, and then after that you have to change the process. So that's why start with the design thinking, and how to get the requirement engineering from your process, how to move it, digitalization with your customer experience. So these are the one that we actually need to embark first before we talk about the technology. Okay, when we talk about digital technology in circular economy, there are various of technology. So one of the things is the IoT. Is more likely is more to the connected physical object to the sensor and or to internet. So one of the system that we already embark is on the product life cycle management and the smart manufacturing and also the waste reduction. The second is one on the robotic and automation. This one we have already have all the most of the industry in Malaysia, and we target by 2030 we have 3,000 factories, smart factory in Malaysia. So we are going to embark this all the circular economy process with our industry. And the third one is on AI and machine learning. So these are we have the large of database that we have, and we want to how do we to optimize the resource usage. And then the fourth one is the big data analytics. So we have this how to do the insight from the database, the large database. So we have a different system that in-house that we have. And then the fifth one on adaptive manufacturing, the cloud computing, the blockchain, and also digital twin, AR and VR. These all eight are the pillars of Industry 4.0. If you want to embark on digital technologies or digital transformation, please make sure these pillars already in hand. Okay, this is one of the use case that already have in Malaysia. So this is one of the project that already this project being funded by EU since 2014. My own project where we convert the calculation, the quantitative calculation, whatever product that being developed in Malaysia from cradle to gate, or you can calculate from the cradle gate in towards to the grave. So the calculation how it produce the emission, these are already being used in Malaysia, and we can have this product maintained with what emission that we have. Okay, it's good for the product that's coming in Malaysia or the product that will be exported to overseas. And then the second thing, this is under my department where we do this 3D and 4D printing. So we are actually doing some initiative on the most likely on the medical product, medical application. So we use the reverse engineering where we help hospital, we help doctors to get their own operation before enter the operation theatre. They have to use this some kind of the 3D model to help them before doing the operation, whatever. So we have some experience in biomodeling and granoplasty. We have helping our patient on ONP patient. We have on part of digital anonymity and also augmented reality and also the clear aligner. So these are the medical application that we use using the 3D and 4D application. And then next, our success case are more to the CRM idea. We are using the AI and also the machine learning. So what we have is right now, when industry are translating their process from digitalization and digital transformation, there's a lot of paper they need to transform, right? So what we did is, what they have to only train the model to get the information so that whatever they input, the document that they already scanned into the system, into the ministry, checking, so everything being done by the AI. So these are one of the system that we already developed. Idea is the AI-based automated data extraction API for dynamic paper-based document. It's only an API that it doesn't disturb your initial system that running right now. Okay, and then the last but not least, our success story in the blockchain platform. So we already developed our own blockchain platform where right now we start with the certificate. So in Malaysia we have a different, it's hard for us to trace some certificate. For example, if you pursue some doctorate certificate like PhD master, how to actually have the genuinity of that certificate. So we use this platform actually to how you sign in and blockchain it, and then we stamp it and you can scan it using the technology that CRM has. CRM has our own platform on blockchain. So these are the challenge and opportunity that we already embarked during our development. So can you see that the challenges and opportunity is definitely will raise on part of how you implement it from yesterday, today and tomorrow. So from yesterday, the complexity of implementation, yeah, we had to actually change the ideation, the process, the manual process of what Malaysians have in manufacturing and agriculture. So that what is the integration digital solution that we need to do. And then we have this digital divide. So we can have this, some community are left out behind. So we are missing out on the green technology here. And then we are looking towards to also the challenges on high energy consumption. When we talk about data centers, blockchain, AI, everything consumes the significant energy. So this will increase the carbon footprint, and also if let's say they don't think about the renewable energy. So the opportunity what we have is now how to optimize the resource management. So that's why we have to start with the change mindset. Change management. This is the one that you need to have this IoT. You have to have the AI. You have to implement the big data. So that the optimization of water, energy, and the waste of sector manufacturing and agriculture will be embarked. So, and even we have here right now, we are consume awareness, behavior change to all the platform educate the sustainability. So there are various of roadmaps, various of awareness, various of conference that we've made in Malaysia, so that we have these some foster changes and also eco-friendly practices. And even we have towards to the circular economy support on part of digital solution. For example, using the 3R or 5R, how to track and optimize using the product lifecycle management and also the supplier change management. So, end of my slide is our future outlook. So, what is our future outlook in the digital technologies, that how you even the industry and aspect of daily life, creating an opportunity for innovation, effectiveness and connectivity. When machine, you can measure the efficiency, but how you measure human. Thank you from me.
Thank you very much for Matt Tuselim for sharing SRIM's inspiring approach to harnessing digital technologies for green initiatives in industrial applications. And thanks for showing us how circular value creation and sustainable development are linked to each other. Now, if we move on, I regret to inform you that Professor Burcu Özsoy from TÜBİTAK Marmara Research Center couldn't join us due to a last-minute setback. So I will do my best to step in and carry on her session. I'm not someone out of the box. I also work at the TÜBİTAK, so I'm familiar with the institution and also the research performed in Marmara Research Center. Yes. Okay. Yeah, if we start with the introduction of Marmara Research Center, they have been performing research on materials and process technologies, energy technologies, climate and life sciences, and also Polar Research Institute. Based on what? Of course, we have an annual presidential program for 2025, which is the combination of skilled individuals, strong families, and healthy societies, disaster-resilient areas, and sustainable environment, which will be the topic of tomorrow's one of the sessions, session 5, justice-based democratic good governance, stable growth, and strong economy. But when you see it here, with a strong emphasis on green and digital transition. Why? The target sectors are all in high and medium-high technology fields, aiming to reduce technological dependency and support structural transformation in manufacturing. What are these critical areas? They are in chemicals, electronics, and automotive sectors. What are our goals? By 2025, medium-high tech exports are projected to grow from 38% to 39.5%, with high-tech products rising from 3.9% to 4.2%, reaching a combined share close to 44%. Of course, our ministry has a support program on green transformation too. What we are objective to support investments that are compatible with the circular economy approach, conserve natural resources, contribute to climate and sustainability goals, and aim from resource efficient and low carbon production. To-do list for investors are prepare a roadmap report containing the green transformation practices to be carried out on the facilities bases within the framework of the green transformation strategy. Submit at least one project proposal to be implemented during the implementation process of the roadmap report. Follow procedures for monitoring, revising, and closing of projects. What are the incentive mechanisms? What exceptions, custom duty exceptions, tax deduction, insurance premium, employer share support, and interest or divided support. These were on the green side, and we have a national artificial intelligence strategy for 21 to 25. This is the first national strategy document of Turkey in the field of AI. Its vision is creating value on a global scale with an agile and sustainable AI ecosystem for a prosperous Turkey. What are our strategic priorities? The first one is training AI experts, so human resource, and increasing employment in the domain. Supporting research and entrepreneurship and innovation. Facilitating access to quality data and technical infrastructures. Regulating to accelerate socio-economic adaptation. Strengthening international cooperation. And the last one is accelerating structural and labor transformation. Besides strategy and policy documents, what we have been performing. With cooperation and collaboration, as you see from our projects, from now I will continue to present you some of the project examples. This is one of the projects supported by EU, enhancing the scientific capacity of the field of smart environment technologies for climate change challenge. This aims to improve research and innovation capacities in key applications of smart environmental solutions for the climate change challenge in 4 targeted areas. These are wastewater treatment, agricultural water management, coastal management, and air quality. And digital transition offers the potential for significant environmental benefits by increasing efficiency and advancing sustainability practices. We will get impact on the digital transformation of the environmental sector at the core of the green transition by targeting water protection, environmental sustainability, and enhancing coastal protection. Let's continue with the other project. Here, our objective is to enhance accuracy of low-cost air quality monitoring systems using AI-integrated field calibration methods. To use AI-based optimization models for the determination of monitoring locations. The system continuously monitors various environmental parameters such as temperature, pressure, humidity, oxygen level. This cost-effective system modernizes existing air quality monitoring infrastructure by delivering real-time, high-resolution data and contributing the green transformation of urban areas. The use of artificial intelligence to support the digital transformation of air quality monitoring. Another example of green and digital proposal is aims to ensure sustainable textile production by integrating AI applications into textile production process to recover and to reuse the washing and reusing effluent from textile dyeing operation using an automated AI algorithm without operator control. By improving process control through the integration of AI applications such as ensuring the efficient use of water, increasing wastewater recovery rates and reducing the use of chemicals will enable the textile industry to achieve green transition goals more quickly and effectively. Wastewater recovery, reduction of groundwater withdrawn and reduction of wastewater discharge is around 20 to 30%, and the reduction of chemical consumption used in dyeing process is between 10 to 50%. We also develop PM-type electrolyzer and to make it ready for field application by running it in the laboratory environment, which is in TRL level 6. Module design, preparation, manufacture and testing the components were completed and 77% module efficiency was achieved. This project received the ICCI 2023 Energy Award in the hydrogen technologies categories. The next one in hydrogen is South Marmara Hydrogen Shore Platform. What we object with this project is to develop again a PM-type electrolyzer with 30 kilowatt capacity, 30 bar working pressure, and with this hydrogen production with the 99.5 purity. This project for 250 kilowatt electrolyzer development has been already started according to the results we received for this project. In this project, you see 37 partners, strong industry, academy, and research cooperation. So it's a very good example of cooperation project. What we object here, this platform will convert it as a fuel cell, battery, and range extender hybrid HDVs. And the integration of fuel cells into existing heavy commercial platform, development of systems in which FC platforms will be used both as range extender and main propulsion elements. The demand for zero emission vehicles is increasing day by day within the scope of green transition. It is predicted that 400 million fuel cell vehicles and 30 million trucks or buses will be on the roads in the world by 2050. So the project is expected to result in emission reduction and energy efficiency, energy supply security. Another project on renewable energy, hydrogen shore, so South Marmara Hydrogen Shore, object to produce 500 torrs gigahertz per year to demonstrate its use in industry and for power generation for emergency applications. TÜBİTAK Marmara Research Center's main task in the project is to develop fuel cell-based power generation systems at the TRL level 8 for emergency applications. This is the first project in Turkey based on Hydrogen Valley concept. There are 16 partners in total, including 13 partners from Turkey and 1 participating partner from Germany, Italy, and Morocco. Within the scope of green transformation, technologies within the hydrogen value chain are emerging as the most important element in zero carbon strategies on the global scale. This project will be the first step in the transition to regional hydrogen economy in our country. Development and demonstration of hydropower technologies to recover hidden hydro in water drinking networks aims to reduce the corporate carbon footprint with isolated electricity production in the drinking water network within the scope of, again, green transformation, increasing green energy integration and diversity in order to decarbonize cities in line with our 2053 net zero carbon targets, based on digital transformation of water supply infrastructure, unmanned operation with anomaly detection, producing hidden energy from the friction in pressure breaking valves in agricultural, irrigation and drinking water networks. Another project, but not on hydrogen, this is on agri-food and potato processing chain from farm to fork through innovative data sharing. Objects to investigate, develop, test and use state-of-art data sharing technologies in the whole potato value chain from producer to consumer to support data-driven decision-making and to increase transparency and sustainability at a European scale. Extending the existing data sharing from a regional initiative to the European level, adding data elements on integrated sustainability covering the whole ecosystem end-to-end to support making the potato processing chain future-proof of sustainability. We have partners from Belgium and Poland. So as I said, these are all project examples from the result of co-creation and collaboration. Thank you very much. Okay, I think we can move on to our panel session. And at this point, I would like to open the floor for any questions. Please feel free to ask your questions to the panelists. If there aren't many questions from the floor, I can start with a question to kick things off. Okay. If no questions, okay, first question to Professor Wang To. Again, thanks very much for your nice talk. How can the principles of a circular economy be integrated into the development of digital technologies to ensure a green transition?
Thank you. Hello? Oh, good. So I think that's a very good question. Actually, my talk, maybe I'm presenting from one direction, but now we go to the other direction. One direction means the digital technology, the digitalization for, let's say, sustainable development, for environmental conservation, for circular economy. Now we go back to see how the circular economy can help for the digital economy, right? Actually, I think there are probably a few perspectives I'd like to share with you and discuss with you. Well, the first one is for the e-waste recycling, it's not a new thing. Actually, we are doing e-waste recycling for a long time. The reason is the e-waste, the electronics are often quite valuable. For example, maybe some of the numbers, 4% of gold, silver, and 1% of copper, maybe more than 20% of lithium and cobalt. They are used by just two products. One is cell phone, another is personal computers. So we say we recycle those things. It could be, very profitable work, right? That's one reason. And now, because of there's some critical materials we call not only useful for digitalization, for digital products, they're also quite important for the green energy transition, like copper used in electric vehicles, like lithium, like cobalt. So now the importance of e-waste recycling, I think, may be somehow at a higher level than what we did maybe 10 years ago or 20 years ago. And the new thing, the new progress is now we are trying to expand the circular economy or the recycling industry from recycling valuable materials to recycle or to safely treat the less valuable materials. Like the low quality plastics. There's some new thing we are doing now, and also we're trying to develop the circular economy not only for material products but also for services. That's something we are doing now, and we think the industrial corporations, they are all through the time at the front line for the circular economy, and now we're also happy to see some very good, examples. For example, for data centers, we know there are a lot of programs for low carbon or for carbon neutral data centers. But recently, for example, Google, they promote, they call the zero waste data centers, and Microsoft, they call this the circular data centers. And all these things are doing from the circular economy perspective to mitigate the waste generation and to somehow improve the efficiency, material efficiency and resource efficiency for the servers, for the data centers, and also, the system boundary could be even bigger. For example, in Google's zero waste data center plan, they also deal with the food waste because one data center, especially a very big data center, could somehow have more than 1,000 employees. So they generate food waste, then recycle food waste, and also construction and demolition waste. That's another big issue in Google's zero waste data center program. So I think that's some of the information I'd like to share with you, and that's my answer. So I hope this could be helpful.
Yeah, it's very helpful. Thank you very much. And what collaborative strategies can be employed to ensure that technological advancements do not compromise the Earth's well-being?
The Earth's?
Yes.
Again, very good question, but somehow the question is too big, for me. How to
start with the small part.
I can only provide some of the opinions, maybe from my field, my understanding and my majors. So a few years ago, Professor Du and our team actually will propose we call a system plan, a system solution for the waste management in China. We call this we call this how to translate. We call these three wholenesses or three totalities, 4 flows and 5 institutions. The three wholeness means for waste management and recycling, we need all the stakeholders, from recyclers, let's say, to the waste generators or producers, then from, let's say, the companies to the public, to the government, and also to NGOs. They all take their responsibility. That's one whole. Another whole is we call whole processes. Waste is maybe a part of the material circularity in our society. So we also need some, work to the upstream processes, from production to product and service design, and to, let's say, some of the regulations, and also from the consumption process, we hope some green consumption, environmental friendly behaviors can be adopted. And that's the recycling. So all the processes should be a part of this strategy. And also we call the third wholeness is the whole area. Or for your question, maybe the whole world, because many of the environmental challenges like climate change, like plastic pollution, they are not a local issue. This is the worldwide issue. So if only a part of the country or a part of the communities, they take actions that the other part left over, I think we cannot solve this problem. So that's the three wholeness. The third wholeness we call the whole world or the whole area. Then in terms of the 4 flows, we think is somehow we develop technology without compromise environment, Earth system. We need to optimize the 4 flows from the beginning, means the flow of materials, the flow of information, like we are talking today, then the flow of capital. This is quite important. We must make the recycling industry can get money. Then the system can work more fluently. Then the last flow is we call the environmental impact flow or environmental impacts. We need to take all these things into our plan for a system plan, the system optimization. Then to make these things into reality, we think institutions, policies, mechanisms are quite important. So we just point out several, we think, very important institutions. For your question, I think one institution is somehow, it's also somehow quite big, but we must know the planet boundary. Where is the planet boundary? So the resource boundary or the environmental capacity boundary. And with this boundary, so that we can allocate the resources of the environmental capacity in a better way, maybe a more equal way and more efficient way. So that's it. Then we need some institutional reforms. Then also there are some other things I think quite important. One is we need to make this somehow technology or technological products. Make them. We must make. These products quite sustainable or the earth affordable. I think that's one issue. But the last thing is all these products, the green products or sustainable products or services. Once they have been made, they must be accepted by the public. What's the new institutions and or regulations can make the public, accept to buy, to use these products, I think is quite important. So I just gave you an example we are doing now for the sneakers case I introduced. Actually, how to recycle the sneakers. The technology is quite easy, but the question is we must make the consumers, the public, to join this program. That's why we are working with Alibaba, the internet giant in China, because we develop an app in Alipay, quite often used app in China. Then in this system, if one pair of sneakers being recycled, then there's we call a green energy credit, or green credit being given to the people, who recycle, who use this app to recycle sneakers. Then with this green credit, if they accumulate enough green credits, then the green credits can become cheap. So that's a program promoted by Alipay, by Alibaba, called the Ant-Forest program. So that's a very successful, program we are doing now in China, but also we are trying to expand maybe worldwide. As far as I know, more than maybe 700 million trees have been planted because people are doing some environmental friendly, environmental good things like recycling, maybe energy saving or water saving, so on and so forth. Mm-hmm. Like we don't drive cars, we take public transport, or we drive bicycles, because all these behaviors can be monitored by the Alipay system. If they have been catched up, then the people can get their green credit. So I think that's a very good innovation probably to push the public to join this environmental friendly actions and to do their responsibility. Okay, maybe too much. Thank you.
Thanks very much. Your detailed and insightful explanation about the strategies on our well-being, for our well-being. Thank you. Thank you very much.
Thank you.
Any question? Yeah, please.
Yeah, I'd like to ask, maybe I can speak out. I'd like to ask a question of everyone, really, or try to encourage people to help me to understand something. We're talking about green and digitalization, and everything digital requires energy. And there are some really obvious examples or well-known examples where we use an enormous amount of energy, like Bitcoin mining, and so cryptocurrency, maybe in general, blockchain and things like this. And we know people are even moving intercontinent from one jurisdiction to another to move around the law or to get access to cheap energy. I often wonder what happens on New Year's Eve in Sydney, for example. I haven't been in Sydney for a long time on New Year's Eve, but there are fireworks at Sydney Harbour Bridge. And suddenly there are 1 million people taking photographs of the fireworks. And all of these photographs, first of all, they're taking up space on your phone, but all of these photos are being synchronized to the cloud. And I kind of wonder how on earth the providers of the cloud can keep up with demand for cloud storage, because it's synchronized here and then replicated, synchronized somewhere else. To say it's growing exponentially is probably not the right word, because it's not exponential, but it's very, very fast, enormous growth, and that also takes resources, metals and everything else. So digitalization, a few of us have used the term IoT, and go back 40 years ago, I was studying what I might call information theory, at a time where we asked questions for system identification, models and data, trying to use data to calibrate models in real time. And we asked the question, what is the value of data? And we tried to design data collection systems to have enough data to calibrate the model, but you also don't want too much. Being a water person, I often talk to students or people near me and I say, suppose I want to measure the water level in a lake and I have an IoT supplier, how many sensors do you think they will ask me to install in the lake to measure the level of the lake? How many? Where? How often should they measure? Because it depends on the question. It always depends on the question. If I want the average level of a small lake, then maybe one sensor. And if it's not changing very fast, I can measure once an hour or once every 6 hours. But if there are wind waves, or if there is a long wave that tilts the surface of the lake and it's 20 kilometers across, you know, I need more. But the feeling that I have is that the suppliers of sensors, all they want to do is to sell more sensors and to have you sample much more often. And all of this data is going somewhere to, I'll say, a cloud. So the question, that's my introduction. My question is, does anybody share this feeling? Or, you know, is there a body of work? Are researchers starting to look at this at a global scale and ask, you know, what is the work that we need to do so that we can educate people to kind of cut down the resources that we need in this move towards digitalization? So does anyone have any feelings that can help me to understand?
Lloyd, I have a feeling. I think you've got a point, definitely. The increased digitalization is putting enormous pressure on the data warehouses. As a matter of fact, in Denmark, where I come from, we've had quite a number of data warehouses being implemented. And the challenge I see is that we have a paradox in regulation where the exploitation of the energy that's generated in a data warehouse cannot be exploited because of regulation. And I think regulation, the paradox of regulation is a major challenge for us in mainstreaming our sustainable energies, but also the sustainable exploitation of that nexus potential we have in food, energy, and water. And so the regulation needs to move faster, needs to change faster in order for us to do this transformation in the most sustainable way. To be quite blunt, the data warehouses in Denmark cannot get rid of their heat surplus. They were meant to be exploited by tens of thousands of households, but are not, simply because of regulation. We have the food, energy, water nexus being diluted simply because biogas is being valued higher than exploiting more of the side streams in food production. So that goes directly to biogas instead of being exploited for higher value use. So there are some paradoxes in the regulations that we need to transform faster for us to have a leaner transformation that can also accommodate this increase in digitalization. That's one answer in my view.
Your reflection is quite interesting. I don't have the answer, so I am sorry. Okay, but I guess that there are several perspectives. I don't have the correct answer to you, so I am sorry. Okay, but I believe that there are several perspectives. The first one may be technical or not technical. The first one is everybody's talking about, for instance, IoT, artificial intelligence, and nobody wonders for what, the purpose of that. In my research center, I came from Galicia, Northwest Spain, and we are mainly focusing on digitalization, energy, water, and so on. So we have several fields of work. The first one is how to deal with sustainability buildings in data centers. This is one of them. Not only for refrigerations, only the interior scope of the building and the design and the maintenance. The other is we try to handle something that is called green computing, and when it's possible, we try to put the computation on the edge, not on the cloud. Trying to use only the data you need to support the processes. We also try to deliver or to foster what we internally say or call or name a data strategy. So for instance, we are handling digital twins for bioprocesses, and one of the problems is that we don't have the more accurate sensor, or we don't have sensor. We have to handle with indirect variables and so on. So one of the challenges we have is to identify firstly the data to the final purpose, and this it generates a money saving in terms of during the project development, and the other is social, okay? Because I don't know, I don't have the answer, because for me your question is linking to something that puts the link in the society we are living in, okay? Because we try to estimate the resource for an upcoming imaginary needs, but the question is that we don't answer ourselves, so we don't make a preliminary question, how many data do we need? And we are not, it's like, at least in Spain and Europe, we are thinking about we need, instead, okay, we need only the minimum amount of data, and this is a controversial and quite deep questions, and at least in Europe we are not getting ready for this, because it's not only a matter of legislation. I believe it's a matter of how we understand the society, and this is the key questions, one of the key questions for me. Sorry, because I don't have the answer, as you can see.
Can I say one little thing to finish up, and then you better go to the next person? I do think one of the answers is the question, how little do we need, and also when can we throw it away? When can we throw away all the data that we collect? And I'll tell you a story, an example. About 15 years ago, I had a wonderful year in Rio Tinto, which is one of the world's largest mining companies. In an innovation centre, there were a dozen of us, and I had a one-line job statement. It said, develop and test concepts for the mine of the future, full stop, open cut mining. The next year, or that year was the year of the financial crisis, I lost my job. But when we were starting to look at autonomous vehicles within mines, autonomous vehicles move around with lots of sensors. So they're using sensors for navigation. They're also using sensors to, for example, keep track of the three-dimensional geometry of the mine, and also the mineralogy of all of the surfaces that it could see with multispectral scanners. And then when we look at how much data is being collected, we're asking the question, every vehicle is collecting information. What does it need to process? What processing power does it need on board? And what analysis does it need to do in order to learn what it needs? And then what does it need to communicate with its neighbours? But basically you have to decide all the time, what do I throw away? And sometimes I don't work in the area of these clouds of drones now instead of fireworks, but they're all communicating with each other, but I'm sure it's tiny little packets, and most of it gets thrown away. And I think that's one thing to keep in mind as we move towards IoT.
Another question?
Thank you so much, Maria from Uganda. Just to maybe think through your question of how much data do we need. Maybe like my submission was more on the AI. I just wanted to share an experience from my country. But how much data do we need? Can we link maybe data collection to AI so that we do not have, just now responding to you, that we do not have need to have like really high storage devices so that AI is helping all of us, but is it trusted? So now that takes me back. I appreciate in most of the presentations I heard about AI and the opportunities, but actually in Uganda people are using it in hiding because they're not yet really transformed to trust sort of like AI data. So they're thinking that AI will kill the innovation. So now the question, how do we learn from the other colleagues in different countries harnessing AI to use it in universities to learn so that we do not kill our innovation? Because I've had some colleagues, for example, in the health sector, using AI to detect early cancer. Others are using it to detect maize problems. But all this is not coming through well because it's not trained and we don't trust AI currently. So it is going to also maybe affect our digital transition. So maybe just around the room, how do we harness such an opportunity for us to also grow to the same pace? Thank you.
So that's a very tough question, by the way. We can keep having a discussion for the 3 days just to answer that. So that's tough. But maybe I can approach to that in one of the ongoing projects we are coordinating, and also we're a partner. So it's a much more mature industry. It's on the battery manufacturing where we need to detect the default cells coming out of the production. And in this project, we're collecting data coming from different sensors in the production line. And we're trying to see which of the cell is better to recycle or to send to shredding or to reuse it. What we did is that we defined high-level layout. They call it ontologies. And based on that, we created AI-based data management platform. Basically what it does is that it converts all the data from all the sensors in the production line and converts into machine-readable formats. Just by converting into machine-readable format, it helps you to first reduce a lot of number of processes in the development chain. Second, the energy consumption also reduces on the computation level. This is not a solution yet, but this is a progress in the project we are having. But of course, this is a longer conversation.
I would add to that AI is only as good as the data it's concluding on. So the better the data you have, the more likely it is you can benefit from AI. But nevertheless, it's a two-end thing, because generating much data is, as Lloyd was saying, is also CO2 heavy. I think I agree, it's a difficult question to answer. But I would definitely not use AI if I'm in doubt as to whether the data is any good.
Yeah. One additional information. Artificial intelligence is a quite wide concept. So one possibility. I agree with my colleague. It's a long conversation, but it's to split the problem. Okay, because if we are talking about industry, you need a long pathway to spread data, to identify data. But if you are talking about, for instance, biodiversity or water resources, maybe you can use existing data sources like the NASA or Copernicus, and you can train some researchers in your country, and you can transform data into specific needs to your specific country. For instance, imagine you want to know or to predict flooding events and so on. Okay, and the other is you are focusing on health. It depends. If you have storage information regarding, for instance, the weight or the toll of child throughout several years, you can learn. Okay, and even more, you are talking about economics. You can also identify some trends. And in addition, you can access currently to open data sets. So if you identify open data sets in Europe, in USA, and other countries, maybe you identify possibilities to learn, okay? And how to implement. The other question is, are you talking about capacity building of people, or are you talking about the need of economic resource? I don't know the answer to economic resource, okay, but maybe there are some programs to facilitate training of PhD or students, okay, or even to launch other initiatives to the very beginning learners, to young people in the school and so on. And if you put not only artificial intelligence in the core of the problem, and you're talking about a long-term transformation, talking about digitalization, then it may be easy for you to identify a pathway, a long-term pathway to get the goal, to get the objective. But in any ways, I can share with you whatever you need in my modest experience you want.
Thanks very much for this interactive discussion. I think we can continue this topic during our coffee breaks. And let's move on with, again, data and to Lloyd. In your last slide, you referred to concerns about data security, which is really related with the first question. Can you say a little more about this issue and what we can do to allay fears?
I can. Do you want to go through all our questions? We have time? No.
We don't have that much time, so I will shorten it with just one question.
So I will say that that I've had interesting experiences here in China where basically I can't get access to data. And I mean, even with the project that I referred to in Eindhoven, there are concerns about data security, but they solve the problems related to data security by working on it. And so over here I can't, but again, my question would be to everyone and to think about how do we in the future resolve these fears that would prevent us from doing what we want to do. Because some of those fears are unwarranted. That's my feeling. Especially when we want to help. I mean, I want to do good green things.
So fear will continue. Thank you. And to Dr. Ramesh from Spain, how can successful case studies in digital and green transition be replicated or adapted to different regions or industries?
So the basic way to approach is to create modularity. If you want to replicate a potential solution from any use case to another one, is to have flexibility on your models. For example, you create a dashboard. All these dashboards in the system can be easy to adapt. Just like moving a cursor, like a PowerPoint, it needs to be as simple as that. So flexibility is important in this kind of models. Second is that open APIs. You're working with so many systems, and if you start having closed data, then these machines or these softwares will never going to interact with each other. It's going to start blocking the communications between them. So you need to start working with open APIs. That's where you can easily replicate the model. There was a comment on regulation. You can have one model work in Asia, but then that model may not work in Europe because Europe may have very strict regulation on data sharing or which of the data has privacy content and so on. So we need to make sure that all the models you develop or the software you develop or interface you develop are aligned to local regulation. And the most important thing is the training. If the adapter or the user who's getting a replicated model, if he doesn't understand what he's dealing with, then there is no use of that software anymore. So it's very important that we establish a common training protocols across different regions so that you can have adaptability among different users.
Thank you. And any follow-up question? Okay, I'll continue with our next speaker, Henry Jean Maris. Could you please explain us how can digital platforms be leveraged to create a more sustainable urban ecosystem, in particular to address the high level of food waste?
I think the main thing to keep in mind with regard to food waste is that a large part of that problem stems from inefficient sort of supply chains and demand side problems. So you have stores stockpiling food that will never sell and that gets thrown away. And I think we can leverage digital technologies there to improve the demand side of the situation as well as the production side. So better planning will essentially result in less food wastage in general. Urban areas specifically it's not typical agricultural land. So by deploying novel growing techniques on rooftops, in basements, unused buildings, that sort of thing, you start to shorten the supply chain and that reduces the waste as well. But I think one needs to be careful to not just throw digitalization at the problem as this magic bullet. Then you end up with this whole AI thing of sensorize everything to death and just store it for how long ever you think is viable. I don't think that's a smart solution. I think we need to be very specific in terms of what we deploy. So in small scale pilot projects, sure, sensorize the whole lot while you still figure out what's really critical to measure. But once you've done that, you need to start really applying your mind and figuring out what's critical to measure and why. And in my case, within an African context, I'm sort of forced to do that since the infrastructure does not allow me to assume always-on connectivity or infinite storage. So the limitations in terms of infrastructure forces certain architectural decisions, which has very much, by implication, a good impact on the sustainability of those solutions. Since if I don't have infinite compute, I have to apply my mind much more widely than if I were to assume that I had. So in general, I think digitalization can help by addressing primarily the supply chain thing, but we should be wary of just throwing technology at the problem. It's not going to solve it. In fact, it might even make it worse. Well, it will address the food wastage problems that make that better, but it makes energy problems worse. So the whole nexus thing, I think, is a balance. And if you get just getting one aspect of it right, will sort of throw the others out of balance, and then you have new problems to solve. And I think water particularly is one of those things where you don't really appreciate it until it runs out.
Thank you. Yeah, I understand that we have to be very, very careful with the data, what we need, how long we store, where we store, how big it should be, how long we have to keep it for, and for both food, energy, water. Thank you very much. As I said, I will shorten it. And the next question to our guest, Ms. Nurul Hawai binti Matuselim. I'm sorry if I do misspelling, I'm sorry about that. What are the best practices and successful case studies that can drive effective and comprehensive green and digital transformation across sectors and industries?
Okay, thank you. Right, as what we already explained just now, when we do the best practices and we have the case study together with this, so when you translate something, you must actually have the buy-in, especially from the policymaker, the industry, the experts, the leaders, everything. So that's why the good thing is when you develop something on a particular regards to the circular economy, you need to adapt or adopt with the sustainability design. So that's why you have this approach and the agility. You should have the agility. Not to think about the technology first. Think about the people and process first. How you want to embark some changes that will affect everyone. So that's my answer.
Thank you. Any follow-up question to our guests? I think no. So let's move on for the closing of this session. Thanks very much for your participation first, for your active involvement, and many thanks for our guests, our speakers, for their inputs from their countries, our industries, and from their visions. And also many thanks for the organizer, G3, and WAITRO for this nice organization, bringing us together to work together and succeed together. Thank you very much.